welcome to the Science Trek podcast.
In this episode, we're answering your questions about simple machines.
Joining us today to answer students' questions are John Gardner from Boise State University and Catherine Devine from the College of Idaho.
Here we go!
Hi, my name is Rachel. I'm from Basin Elementary School. My question is, why do we have simple machines?
We have simple machines because we as humans were smart enough to figure out how to do them. Like, they weren't given to us, they weren't discovered, we invented them. And we invented them because we had things that we had to do, things we wanted to do that required more force or more pushing or pulling than we were capable of doing as humans ourselves. So these machines are ways of multiplying our own effort and to get a difficult job done.
My name is Christian and I go to Garfield Elementary. And my question is, who decided that there are only 6 simple machines?
Well, the ancient Greeks actually were the ones that first started giving the terms like machines, like this, the pulley is a simple machine or the wedge is a simple machine. And so he was Archimedes around 10th century BC was one of the first to kind of narrow it down to a pool. And then later on, during the Renaissance scientists started kind of classifying types of tools as simple machines. And I think that it was in the Renaissance that we wound up with the 6 that we call the 6 simple machines.
My name is Blake, and I go to Dalton Elementary School. And my question is, what types of levers do you use, and what types of different things take hydraulics?
So those are 2 very different questions. So I think we use levers all the time, and it's a little hard to see them sometimes. Taking the analogy of a bicycle, I think you could state that the steering, your handlebars are kind of a lever. You're exerting forces at some distance away from the middle of the bicycle to make it rotate around a smaller distance in the middle, and gives you better control. Hydraulics is a more complicated set of machines, and they're using fluid, water or oil, to do something very similar to what levers do, exert a force at a distance and change the nature of the force. Probably the most common use of hydraulics is in brakes of your automobile, or in some of the newer mountain bikes use hydraulics. So you can exert force on your handlebars, on the brake levers, or on your brake pedal in your car, and the hydraulics, the pipe that moves the fluid around, exerts force on brake pads that grab the wheel and make it stop.
Hi, my name is Aaron, and I go to Garfield Elementary. My question is, are some simple machines used more than others?
Yeah, I think that some of them are, just because some of the machines are a little bit more broadly applicable. Like, they have a lot of different ways of using them versus some of them are more specific. And so, for example, wheels and axles and levers are used in all sorts of machines or other more complicated things, and have, you get, like, again, back to the bicycle, it uses wheels and levers. Things like screws are a little bit more specific to a purpose. And so I think those are not used in as many different ways as a wheel and a lever might be. So I think that there are some that get used more often than others just because they have more applications.
My name is Myra, and I go to Garfield Elementary. And my question is, why doesn't homework or thinking count as actual work in a science kind of way?
That's a great question, because most of you know probably thinking or work can actually make you feel physically tired. So work, from a physics professor standpoint, I'm a physics professor, so we think about work as force multiplied over a distance. And so thinking when you're doing homework and you're thinking, you're not actually applying a push or a pull over any distance. And so that's why physicists don't think of homework or brain power as actual work. A biologist or a psychologist might argue that, though, and say that there is actually energy being transformed and burned when you think, and that there is some work there. So to a physicist, I say, no, there isn't any work being done there because you're not doing a push or a pull across a distance. But a biologist might argue that you actually are burning off energy, and that does take some actual amount of work measured by energy.
That's a great answer. If I could just add one more thing to that. Part of what we learn in science is that we have to be very careful about the words we use. Words means very, very specific things to scientists and to engineers and other professions. And work is one of those words that means a lot of things to us as in the common language. Scientists will sometimes use common words like work, but they have a very special meaning for them. So that's part of the confusion we have. as science teachers and people who educate, is to try to help people understand that there's words that have very common meanings, but in a context or when you're talking about science, they mean something very specific.
Hi, my name is Brent. I go to Garfield Elementary School. My question is, why was measuring work named after Newton?
So the unit of work is actually called a joule, or it's measured in energy. Newtons measure force. So imagine a force is just simply a push or a pull, right? And so those are measured in newtons, and they're named after Newton because he was one of the first people to come up with some of Newton's laws, which are laws that measure or kind of talk about force. But work is slightly different than force. Work is force measured over a distance. So if work is in a push or a pull, if force is in a push or a pull, then work is measured in over the distance, how far you push or pull that object. And so that actually is measured in units of joules, which quantify energy.
And if I'm not mistaken, 1 joule is 1 Newton meter.
Yes.
So one force of Newton applied through a meter is equal to 1 joule.
Hi, my name is Shelby, and I go to Kamei Elementary School in Kamei, Idaho. My question is, how do you make a simple machine?
There's a lot of different ways to do that, but I think the easiest simple machine to make is the lever. So you have a long, rigid bar and a rock or some fixed object to lean it against, and then you can pivot around that one object. Wheels are harder to make because they've got to be perfectly round, or they're not very good machines. Another very easy machine to make, if you want to do, is a wedge. So any small block of wood or metal that tapers to a point can be used as a wedge, and you could use it to maybe get under a heavy weight, and it can start moving it up and things like that.
My name's Emilio, and I go to Garfield Elementary. My question is, what is your favorite simple machine and why?
Well, what's your machine? What's your favorite machine?
It's tough to narrow them down. I've been thinking about this. So I think I like pulleys a lot. Anyone who's gone camping and had to hang food away from a hungry bear, pulleys are very good for hanging bear ropes. So that puts pulleys up in the top. I like my bike a lot. So wheels and axles and levers. My bike would not be rideable without those. So it's kind of a toss-up between those three. And then, ramps are really nice. I'm not super strong, so when I have to lift up anything into my house, I usually use it up a ramp on wheels rather than trying to just lift it. So I can't narrow it down. How about you?
I would agree. It's hard to imagine anything we do on a daily basis without all of 6 of the machines. I think wheels are probably the most common one because they're so central to transportation for how we get around, whether it's your bicycle or your car or your skateboard or your scooter. But for some reason, I'm not sure why, I'm kind of partial to pulleys. I think pulleys, very simple little, they're kinds of wheels with rope, and you can just make amazing things. Elevators, right, require pulleys, things like that. So
That's all the time we have for this podcast.
Our thanks to Catherine Devine from the College of Idaho and John Gardner from Boise State University.
And thank you.
Wait! I have a joke this time. Why was the pulley so popular?
Why?
It got pulled up into high society.
Thank you for listening to our podcast. If you want to learn more about science topics, be sure to subscribe to the Science Trek podcast. And for more information about simple machines, check out the Science Trek website. You'll find it at sciencetrek.org. Bye!
Funding for Science Trek is provided by the Laura Moore Cunningham Foundation, the Idaho National Laboratory, and supporters like you. Thank you.